Hi, second lesson then, product of primes. Now we've been doing some of these of our starter activity, haven't we? So new starter activity, following the same format as the last one. Don't forget D is estimate. Pause the video while you attempt these questions, you have 10 minutes. Okay, here are the answers. So you should have got 2 squared times 5 times 7 for E. And C was a bit tricky. Minus 3 times x is minus 3x. And then you've got minus 3 times minus 2. Two signs that are the same, minus 3 and minus 2. Minus 3 times minus 2 is positive 6. Pause the video while you finish marking these questions. Remember to mark in green. Right, so our lesson objective today is to be able to write a number as a product of its prime factors. So we need to know what a prime number is. Now, a prime number only has 2 factors. So 1 is 1 times 1, only has 1 as a prime factor, and therefore 1 is not a prime number. But we do have our prime numbers, don't we? So 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. 9 cannot be a prime number because it has 3, 1 and 9. 15 cannot be a prime number because it has 1, 15, 3 and 5. Mo says that 153 is not a prime number. Is he correct, and how do you know? If we have a look at the numbers, if the last number was an even number, we know it'd be divisible by 2. So that can't be a prime number. A nice trick that you can use for 153, if you add the numbers up together, 1 plus 5 plus 3 is 9. We know 9 is in the 3 times table. So therefore Mo is correct that 153 cannot be a prime number. So have a go at listing, pause the video and list the prime numbers between 30 and 40. And Joanna says 84 is not a prime number. Is she correct? How do you know? So pause the video. Okay, so we should have 31 and 37. We can't have 33 because 3 and 11 and 1 and 33. And we can't have 35 because there's a factor of 5 in there as well. And we can't have 39 because 39 is in the 3 times table. So Joanna says 84 is not a prime number. Is she correct? Well, 8 and 4 is 12 and 12 is in the 3 times table. So she's correct to say it is not a prime number. Pause the video while you copy any of those down that you need. So let's have a look at these 2 questions. We need to write 60 as a product of its prime factors, and we can do it as a prime factor tree as we've been doing in our starter activities. So let's have a go at that. So 60 divided by 3, 3 is a prime number, so we can circle that. 3 times 20 is 60. So let's look at the 20 now. Well, 5 is a prime number. 5 times 4 is 20. So we can circle the 5 because that's a prime factor. 4 isn't a prime factor. So 2 times 2 is 4 and 2 is a prime factor. So our answer to that question is 2 times 2, so that's 2 squared, times by 3 times by 5. Let's have a look at the next one. Work out the value of n and m if 160 equals 2 to the n times 3 squared times m. Now you're probably looking at that and thinking you haven't got a clue how to do it, but you do know how to do a factor tree like the one above. Let's have a look, let's do the factor tree and see how we get on. 160, well 2 goes into 160, so 2 times 80 is 160. 80 can't be prime because it's got a factor of 10 and 10's not prime. So 4 times 20, that's 80. Well, 4 and 20 are not prime, so we can't circle those. But 2 times 2 is 4, and they're both prime. So we can circle the 2's. Let's look at the 20. Well, 5's prime, so 5 times 4 is 20, and 2 times 2. So we've got 2, 2, 2, 2, 2 and a 5. So let's have a look at this. So we've got 1, 2, 3, 4, 2 to the 5 times 5. So let's go back to the original sum. So it said if 160 equals 2 to the power of n, so n must be 5 because we had 2 to the power of 5, and m, the number that was by itself, was 5. Pause the video and have a go at the other two questions. So write 72 as a product of its prime factors and work out the value of n and m if 180 equals 2 to the n times 3 squared times m. So let's look at the 72 first. So 72 divided by 2 is 2. So we can circle that one at 36. 36 isn't prime, it's an even number. Let's have a look at 4. Well, 4 is 2 times 2, so we can circle those. Let's look at the 36 now then. 4 times 9 is 36, but 9 isn't prime, but 3 times 3 is. So let's count them up then. So we've got 3 2s, so it's 2 to the power of 3, and we've got 3 times 3, which is 3 squared. So the answer of writing 72 as a product of its prime factors is 2 cubed times 3 squared. Let's look at the value of 180 now then. As we know, we have to do our prime factor for tree. So 2 times 90 equals 180. So 2's prime, we can circle that. 9 times 10 is 90. So let's look at the 9 side first. Well, 3 times 3 is 9. They're both prime, so we can circle those. Let's look at the 10 now. 2 times 5 is 10, and they're both prime. So we end up with 2 squared times 3 squared times 5. Let's go back to the question again. If 180 equals 2 to the n, well, that's 2 squared, so n must be 2. Times 3 squared, yeah, that matches our answer, and m must be 5. Pause the video now, as Farah is going to come to the front and collect the product of the prime factors booklet and hand them out to everyone. Thanks, Farah. Okay, 20 minutes, off you go.